Hey guys! Alright, today we're going to do Chapter 7, Section 4, which is on permutations. So on your notes, the first thing it says is a permutation is an ordered arrangement of object. So what that means is that with permutations, it's really important that order matters. Okay, so the order that you put things in, you have to take that into account with a permutation. Alright, so our first question says how many different possible standings could occur in the Big Ten Conference? So this is pretty much like what we were doing yesterday with Section 3. And what we want to do is start out with those blanks. So in the Big Ten Conference there are 12 teams. I don't know why, but that means that we want 12 blanks here. Okay, so I've got my 12 blanks. Now I need to think about what the probability I have for each of these spots. So for first place, how many possible teams do I have to choose from? Well, I've got 12 teams that I can choose from. Okay, for second place, now that I've chosen my first place team, I only have 11 teams to choose from. And then I only have 10 teams, 9, 8, 7. You guys get the idea. Okay, basically what's happening here is we have 12 factorial. So that leads us to the permutation theorem, which says there are n factorial permutations of n objects. So if you have n objects to choose from, the different possibilities that you have of arranging those objects is n factorial. And of course, we're talking about permutations, so in a permutation, order matters. Alright, so a permutation, the definition of our permutation is going to be n p r equals n factorial over n minus r factorial. The way that you read this is if you are choosing r objects from a group of n objects, this is going to give you the number of ways that you can permute them or arrange them. So on our paper it says an ordered arrangement of r different objects taken from a pool of n objects. Okay, it might not make much sense now, but as we go through and do some more problems, you'll understand why these are important. So our next question says how many different four-letter words can be formed from the letters in the word equations? The words do not have to make sense. Okay, so if I'm looking at the word equations, that has 1, 2, 3, 4, 5, 6, 7, 8, 9 letters. So basically what I'm doing is I want to make these four-letter words, and I'm choosing these letters from a group of 9 letters. So this means that I'm choosing 4 letters from a group of 9 letters. Okay, so that's going to be 9 permutes 4. Okay, so 9 permutes 4. So 9 is going to be my n value, and 4 is going to be my r value. You always, always, always know that your n value is going to be the bigger value, because you can't choose like 10 objects from a group of 4 objects. That doesn't make sense. Okay, so this n value is always going to be bigger. So if I plug that into my equation here, I've got 9 factorial over 9 minus 4 factorial, which in that case, I know 9 factorial, that's 9 times 8 times 7, all the way down to 1. Okay, 9 minus 4 factorial, that's 5 factorial. So that's 5 times 4 times 3, all the way down to 1. So really, if I think about this, once I get to my 5 here, everything past my 5 is going to cancel. So this is really just 9 times 8 times 7 times 6. Okay, because everything past my 5 is going to cancel out. And that gives me 3,024. Okay, so that's the answer to my first question here. The next question says, how many ways can 120 passengers be seated in an airplane with 150 seats? Okay, again, you're just thinking about a permutation here. So we've got this formula, and we have 120 passengers, and we're choosing them from a group of 150 seats. Okay, so we know that our n value is going to be 150, and our r value is going to be 120. So I've got 120 factorial over 150 factorial over 150 minus 120 factorial. Okay, so if I rewrite this, it's going to be 150 factorial over 30 factorial. Now if you go ahead and try to plug that in your calculator, you're going to get an overflow error because 150 factorial is a huge number, okay, and 150 minus 120 factorial is not so huge, but because this number is so big and we're not dividing it by that big of a number, we're going to get a very big number still. So you can just leave it like this, and I would accept that form if there was an overflow error. Alright, the next question, we want to find n, and these are probably the trickiest types of questions, so it's really important you pay attention to this one. Okay, so with this question, I've got n permutes 8 equals 13 times n permutes 7. So what I want to do is I want to use my definition of a permutation in order to solve for n. So I know that if I rewrite this using my definition, that's n factorial over n minus 8 factorial. And over here I'm going to have 13 times n factorial over n minus 7 factorial. Okay, so now I need to think back to what does a factorial actually mean? I know that 9 factorial, for example, is 9 times 8 times 7 times 6. So what I'm actually doing is I'm reducing each of the values that I'm multiplying by 1 each time. So if I think about n factorial over here, that n factorial is actually just n times n minus 1 times n minus 2, and it just keeps going that way. Okay, so n minus 8 factorial, that would start with n minus 8, and again you're just subtracting that 1 every time, so then it'd be n minus 9, and n minus 10, okay, etc., etc. Alright, so now we can do the same thing on the other side. So I've got 13 times n minus 1 times n minus 2, etc., etc., over n minus 7. I'm going to start with n minus 7 here. And then I've got n minus 8, n minus 9, okay, and I'm just going to keep going. So now what you'll notice is that you can actually start canceling some stuff out, and maybe you don't notice that, but let me just show you why. If you look at just this side right here, okay, eventually I'm going to get down to n minus 7, right, and then it'll be n minus 8, n minus 9, continuing on. So this and this are going to cancel out. So that means that on this side of the equation, all I have left is 13n, n minus 1, n minus 2, up to n minus 6. It goes right up to the one before where you cancel it out. So right before n minus 7 would be n minus 6. Okay, so that's all that's left on that side of the equation. Now I'm going to do the same thing over here. So over here I have n minus 1, n minus 2 forever and ever. Okay, and on the bottom, I've got n minus 8, so I'm starting with n minus 8. That means that from n minus 8 on, I can cancel those, which means this is going to go from n to n minus 7. Okay, so now this is the equation I have. So I've got from n to n minus 7 over here, and over here I've got 13n to n minus 6. Well, now I can start canceling stuff out on both sides because I know, for example, over here I have an n and an n. I have an n minus 1 and an n minus 1. I have an n minus 2 and an n minus 2. So over here I can cancel all the stuff up until n minus 7 because I've got everything up to n minus 7. So what I have left is just n minus 7 equals 13, which I can just solve and get n equals 20. So I know that my n value in this case is going to be 20, so I know that 20 permutes 8 is equal to 13 times 20 permutes 7. Alright, there's one last thing I need to talk about in this section, and that's just the fact that if you ever see 0 factorial, 0 factorial is actually equal to 1. Okay, and I know that doesn't really make a lot of sense, but the reason that we use it is because when we talk about factorials, generally we're talking about permutations, so we're talking about choosing a certain number of objects. Okay, so for example, we talked about the formula earlier with n factorial, so I have n factorial ways that I can arrange n objects. Well, if I have 0 objects, I don't necessarily have 0 ways to arrange those objects. I actually have one way that I can arrange those objects, and that is that I don't arrange them at all, okay? I just don't have them, okay? I know that doesn't really make sense, but we just need to think about that in the actual context rather than mathematically. Okay, so 0 factorial is 1 always.